Let's wrap these up. Last two, letter G. If you remember, we have that half angle formula, and I said by itself is not good, but with the squared, it's much easier to work with. Let's change colors here. There we go. Sine of theta over 2, not pleasant. And it's plus or minus the square root of 1 minus the cosine of theta, all over 2. That is very unpleasant. However, this is sine squared of that, which is much nicer. So when you square a plus or minus, you do get a positive. Positive squared is positive, negative squared is positive. When you square a square root, you're just left with the radicand. So in essence, this just becomes 1 minus the cosine of theta over 2, which is much more pleasant than just plain old sine of theta over 2. So that's the substitution I'm going to make to begin with, and then we'll see what we have from there. All right, so sine squared theta over 2. Again, this isn't a proof, so I'm not so worried about showing every single step by step. Just go right into it. Sine squared is 1 minus cosine of theta over 2. Plus cosine theta equals 1. Now here, to clear that denominator out, I'm going to multiply both sides of this equation by 2. All right? Now, that just means I'm going to distribute that 2 through this quantity. And the whole point is to cancel out the 2 denominator here, and it does that. So 1 minus cosine theta when I multiply it to this, and that's just plus 2 cosine theta equals 2 times 1 is 2. Combine my like terms, and I get 1. Those combine into cosine of theta, and that equals 2. Subtract 1, that's cosine of theta, is equal to 1. Which we do recognize as quadrantal. And probably the easiest way to handle this, simple picture, just go to the graph of the cosine of theta, as I said many times before, to handle the quadrantals. Now, when it's square root of 3 over 2 or 1/2, the graph is not going to help you much. But for quadrantals, very, very helpful. So, let's graph our cosine. And we can see where cosine of theta is equal to 1. That would be 0. Radians are 0 degrees. And also 2 pi or 360, but that's out of bounds anyway. So looks like we have but one solution here for degrees. That would be 0, which means only one solution for radians. That's 0 radians. And as far as all values are concerned, we go 0 plus 360k, or like in the last problem, we'll just do 360k. Or 2 pi k if we're talking radians. So 0 to 360, 0 to 2 pi, all values. Right? That one actually wasn't too terrible. At least, yeah, as bad as it appeared. Okay, letter H for these problems. If this were cosine double angle or cosine 2x, I'm not going to go through the process that I'm about ready to do, but we could. But 5x, forget it. There's no easy formula for 5 and 7 and 3s and 4s. So we just do a substitution, if you remember. And the substitution is we say let u equal 5 times x. By letting u equal 5 times x, we come up with a simpler equation. We get the cosine of u equals the square root of 3 over 2. Now, solving that is no big deal. As far as principal values are concerned, you just do the cosine inverse, square root of 3 over 2, which gives us 30 degrees. 30 degrees. All right, so cosine inverse, square root of 3 over 2 is 30. Now, as far as 0 to 360, where else is cosine positive besides quadrant 1? Well, the answer is it's also positive in quadrant 4. So we draw a reference of 30 in quadrant 4, which makes for 330. So I just put next to this 330. Right? So from there, if you remember, we would say u equals, and we would do 2 branches here. We do 30. And then we'd list a whole bunch of angles coterminal with 30 going in the positive direction. And we do the same for 330. Oops, 330. All right. Now, from there, need our old calculator. Not that it's really difficult to add 360, but you definitely don't want to make a mistake. Plus, the calculator makes things real easy once you add it a couple times. So if I add 360 to that, then I can just keep hitting enter. So I get 750. Next one's 1110. Next is 1470. 1830. 30, and I mean, we can keep going here. If we need more, we'll list them. But we've just listed a bunch of coterminals. Now I do the same thing for 330. 690 plus 360, 1050. 1050, and then we keep going. Enter 1410, 1770. 2130. Again, we can add more if we need. And now, the reason we do this, you understand these angles here that we got, like, for example, 1470, they're way out of bounds for 0 to 360, right? However, the idea is we were not asked to solve this equation. We were asked to solve this one. So we have to resubstitute. In other words, u is equal to 5x. So we're really saying 5x is equal to all these angles. So if you just pick a random one, say 1050, if you say 5x equals 1050, we have to solve for x. So we take 1050 and divide it by 5. We get 210, which is within our bounds of 0 to 360. So that's what we have to do, is take all of these answers and basically divide them by 5. So let's do that. We'll just say x now equals, take all these, divide by 5. 30 divided by 5 is 6 degrees. Then we just go 390 divided by 5 is 78. 750 divided by 5, that's 150. So we can handle some of these. 11 5, 222. 1470 divided by 5 puts us at 294. And if you check the next one, this 1830, and divide it by 5, it puts you at 366, which is 6 degrees over our bounds, actually a little bit more than 6. It only goes to 360, so 1830 is a little too far. Makes sense that we got 5 solutions here. That 5x, remember, horizontally compresses the graph of cosine by a factor of 1/5. Okay, finishing these off, take 330 divided by 5 is 66 degrees. 690 divided by 5, 38. 1050, 5, 10. 1410 5, 22. Getting close. 1770 divided by 5 is 354. And you can see we're only 6 degrees away. 2130 is going to be out of bounds. Oops. 2130 divided by 5. That puts you at 426, which is well beyond what we wanted. So solutions, you got 10 of them. Now, real quickly, we could probably show a graph of this. I already have sine, cosine in here, right? So I have the two functions entered in, the left side, the right side. So the left side, I have the square root of 3 over 2, that's y2. Cosine of 5x is y3. Now, we'll put in the normal cosine function just for a comparison here, so we can see what happens. So probably want to distinguish that one. Remember how we can make that bar a little thicker? Just scroll over to that slash to the left of y1 and hit enter. And if we go to graph this, well, you can see I've already graphed one. That that last thing graphed is just the cosine of x, right? If I get rid of that, it'll regraph the entire functions here. I'll stop shaking. That's the square root of 3 over 2. Then you got the cosine of 5x. Now, it's going to be kind of tough to see that first solution right real close to the y-axis. That's 6 degrees. So if I zoom in on that, it is hitting there. Let me try. Zoom in. Right, I'll just get to that locale. All I'm doing is going to zoom, and I'm moving my cursor to that location. Because I'm looking at it and it's like, does that really hit? I don't know. And it just shows a closer shot, a close-up shot here. Yep, there you go. So you can see that it does hit. That's the square root of 3 over 2, that horizontal line there. And there's your cosine of 5x. It's hitting, and it's going to be at 6 degrees. Now, 6 degrees in terms of radians, that's nothing pleasant to look at. So it's, as far as my graph is concerned, because my mode was radians there. I just graphed from, what do I got? Well, the window's changed, but you can see how this works. We did get 10 solutions overall.